I'm going to share a slideshow through a screen video with anyone who's interested in seeing kind of what we do in science. The kind of big goals of the program are that students will get to think and do things like scientists do, and we integrate all the sciences together, and that there's some pivotal concepts that students will learn more deeply. So we try and approach learning through multiple approaches. So that would include doing experiments and discussing and writing and modeling, sketching, many, many ways. And that we use technology to not only kind of produce work, but also to measure and facilitate experiments and accurate data. That there really is a process of kind of doing multiple experiments, or what I call them stations, and trying to see the relationship between things that they figure out in stations. So we might do an investigation, take some data, observations, go home and reflect in our notebook, write up our ideas, then come to class and share ideas with the rest of the class, and then approach a new experiment. And do the same thing. And then in the end, after having done a number of experiments, try and put it together. Try and understand how things relate, how what we learned in one experiment might help us explain something that happens in another experiment. And eventually we get to the point where we are also looking at how a textbook would relay the information that we've kind of discovered on our own. We might do a project also to show what we understand from our experimentation. So it's a flow, and then we would start a new unit. In 7th grade, we learn a lot of various earth science. Although this looks a lot like a list of unrelated things, that they are very related. And so we're showing the interconnections between concepts a lot. There's various resources that that students have access to. On Google Drive, the school has kind of an umbrella Google Drive. There are a few folders that students will find. One of them is called Shared Edit, and it's used when the task involves groups of students entering data or information in one document. So we do that especially during stations when students are doing experiments and we want to kind of average our data and our measurements. There's also a folder called Shared View, and that's used when students need to make a copy of a Google document and use it individually for something. So in the Shared View folder, you would find a template for their notebook. So they would make a copy of it, and then that would become their new notebook when we start a new unit. On Keysnet, there are topics pages. I make a new topics page for every unit, and that's a great place to find the experiment procedures, the class notes, homework assignments, links to video instruction, and many other things. We also have a series of textbooks. They're unit-based Glencoe Science textbook by McGraw-Hill, and these textbooks include features designed by National Geographic. There's both physical and digital versions, and the digital versions include audio as well, which is nice. So for assignments, kind of organization, a lot of assignments will actually be turned in on Google Drive. That's where their notebooks are. That's where we might take class notes. We might put stuff relating to projects, textbook reading notes, any test corrections. So basically the students will make a folder on the Google Drive. They'll share it with me, and in their folder they'll make some subfolders to organize the stuff that they're sharing with me. I also create a folder that I share with the students. It's just named after their name, and when they go to look under Shared with Me, they'll find a folder that is their name, and they'll see that I created it, and I put assessments in there. So you'll find assessments and summary grade sheets in there. Homework, there's different weighting. The homework is 20 to 30%. You can kind of read about the policy there. There's a late policy that all of the teachers are following. There's the science notebook quality, where I'm really looking at the writing of the student in their science notebook, how they're organizing data, how they're representing their information, how they're relaying their thinking. So that's an important piece of their grade. Projects, sometimes we have projects, sometimes we don't, but they count for 10 to 20% of the grade. Tests and quizzes are also 20 to 30%. Participation and focus, 10 to 20%, and there's some details about how I collect that information. Student expectations, basic stuff, arrive on time, get your stuff out, get ready to learn, clean up after yourself, work well with your partners, and take responsibility for your part of the class process, stay on task, look for ways to improve experiments and treat materials with care, and participate and give your best effort. So the bigger approach I was talking about earlier, about kind of taking pieces, like discovering different components and trying to put them back together. So physics is a big part of that, because a lot of phenomenon and a lot of science can be explained by the underlying physics. So most units will have some physics within them. And then there's sample questions. So this is a particular unit on solar and lunar eclipses, where you can see some of the sample questions that came with it and some of the activities that they would do. One of the activities would involve making shadows, and we look at kind of this, we use a couple light sources. One is a light bulb and a light box. You can see that the filament is pretty big in that particular light bulb. And if you watch, you can see that when you make a shadow with this particular light bulb, you get a lot of fuzzy stuff on the top and around it. That's actually called the penumbra of the shadow. And so students would make observations about that and measure aspects of that. Then we use another light source, mag light, much smaller light source. We do the same thing, and we make shadows. And we check it out, we notice that the edges of the shadow with the smaller light source stay very crisp. So students do a lot of thinking about why this would be true, and they draw kind of physics ray diagrams, and then they get this information into their notebook. And so they would have their materials and methods, they would have some data, they would have some diagrams, and then some observations, and then a results and discussion section, and a new experiment design and hypothesis section. This is one example of a digital notebook. This is a part of an example with a physical notebook. And then they would do some experiments that involved using a software that allows you to kind of look at different kinds of eclipses. This one here, you can see that the moon, is a lunar eclipse, goes all the way into this dark part. That's the umbra, and then out through the penumbra. That's kind of interesting. Here's another one that shows the moon only going part way in, and so that's a little bit different than the earlier one. So one of the activities they would do is they would look at multiple eclipses. Here's a solar eclipse. And they would not only kind of look at the shadow of the eclipse, but they can also, in this program, go to a specific place within the shadow and see what it would look like. So in this situation, they can go to the umbra and they can go and look at the sun, and they can see that the moon is completely covering the sun. If they were in that umbra, what it would look like. So they use all, like, they look at a bunch of different eclipses, and they have to sort them into categories. And so they look at a bunch of different lunar ones, a bunch of different solar ones, and they come up with a category system that they think would be a good category system, which is, again, something scientists would do. In this particular unit, there's a bunch of stations, And each station kind of helps explain something else. So station 1 leads to discovering the physics of shadows. Understanding station 1 is necessary to understand station 4 in terms of why there would be different categories and how those categories would work. And then in the end of the unit, they're putting lots of different aspects of it together. Information about their types and frequencies, about the orbits and solar system geometry to kind of really understand the content more deeply. So that's kind of the idea, that each grade has these units where they're looking at different things and putting it together. And then there's actually an aspect of connecting things between the grades. So something that might be introduced earlier to a younger grade is explored more deeply in a following grade. And really overall, I want kids to enjoy science. So I want them to think like scientists and do experiments and analyze and discuss and report. Please feel free to email me or call me if you have any questions.